Hey, it's Mr. Allred here. The next thing we're going to tackle is formulas. So a formula is an equation, but in general we have multiple variables in it. We have many things changing, so we're looking to figure out how those things interact with each other. So multiple variables, but we don't always treat them all as variables. But down here we have two examples. The first one, A equals 1/2 BH, right here. First one. That's actually the area of a triangle. So in theory, you would use this formula if you had the base and height, B and H, of the triangle, and you would calculate the area. But because there's three variables, if you knew the value of any two, you could use solving methods to find the third. So if you wanted to use a certain amount of area and you wanted to be so tall, you could calculate what the base needed to be. Okay. On the second one here, P equals A plus ART, that's actually an interest formula, but it has four variables in it, P, A, R, and T. And we could use our solving methods. These are simple linear equations if you only treat one of these as a variable, as we'll see in some examples. But you could get any one of the variables by itself. Okay, so we're going to use our regular solving methods to do this. So let's jump to some examples here. So let's start with that A equals 1/2 BH. And let's say we want to solve for B. So let me rewrite that. Let's actually make it clear. Sorry. Solve for B. So the first thing to do is look at this thing and see where B is. It's right here. So we treat everything else like it's a number. So we move it around like it's a number. B is the only variable. So let's go through our solving steps. The first thing would be to, we have a fraction with that 1/2. So since that's 1/2 on the bottom, the LCM would be 2. So let me rewrite it. A equals 1/2 BH. So if I'm going to be consistent with the steps I use for a linear equation, I'll multiply by 2, and that will hit the first and the second. It's important to realize that 1/2 BH is one thing. So if I distribute that, on the left I get 2A. Let me do this the way I did it before. 2A. Equals 2 times 1/2 BH. So these cancel out. So now I'm at 2A equals BH. And once again, it's important to realize that we're trying to get B by itself. So really, all my B terms are on the right. B and H, we're treating H like a number, so that's on the right. My non-B terms, the terms that don't have a B, are on the left, 2A. So I'm at the point where I don't really need a distributive property. I don't need to move anything from left to right. So I need to divide by the coefficient. And in this case, that coefficient is H. So I'll divide both sides by H. So on the left, I have 2A over H, and on the right, I have B. So the important thing, if we're solving for a variable in a formula and we don't have any numbers or any values for the other ones, we're not expecting to get a number. We're just really rewriting the formula to see if we understand the solving techniques. Because I know a lot of simple equations, you can look at them and you might try 2 or 3 numbers and get the answer correct just by guessing. But you want to see if you actually understand the solving techniques. So if we want to get B by itself, it would be B equals 2A over H. All right, so let's try another example. So let's go with the P equals A plus ART, and we want to solve for R. So we could isolate any of these variables. P is already by itself, but we want to focus in on R. So let's figure out where R is, and let's use our steps to get R by itself. So if we think about it, there's no fractions here, and there's no parentheses. So we're free to start moving things around. So the idea that we want to start with there is we want to add and subtract terms across the equal sign, because we want to get the R term on one side and the non-R term on the other. So I'll leave the R term on the right, and I'm going to subtract A from both sides. Okay, I'm subtracting a quantity from both sides, so it doesn't come from every term, it comes from both sides. So cancels out on the right, so I have P minus A on the left, and I have ART on the right. So all my R terms are on the right, and my non-R terms are on the left. So keep in mind that I'm trying to get R by itself. So the next thing is that since all my terms are on opposite sides of each other, I'm ready to divide by the coefficient. And it may not be so obvious, but what is multiplying R here? The answer is AT. So I'm going to divide both sides by AT. So the A's cancel out on the right hand side, and so do the T's. So in the end, the only thing left on the right hand side is the R, which I was trying to get R by itself. Now I don't have to do anything fancy with the left. If I see something I understand how to simplify, I will. But let's just write down what we've got. We've got P minus A over AT, and that'll be R by itself. So if you don't understand how fractions reduce, especially more complicated fractions, don't attempt to try and cancel those A's out, because in this scenario they should not reduce out. Okay, not the way you're looking at it. Okay, let's do one more example with this formula. Let's make it something that you may hope you never see. Okay. But let's go ahead and take the P equals A plus ART, and let's take it in a different direction. Let's solve for A. Okay. So take a moment to think about what that means. We're going to try and get A by itself. So let's just kind of focus in on all the A's. Well, A doesn't have any exponents, roots. It's not in the denominator. So it's a linear equation with A. Okay. So let's think. No fractions, no parentheses. So the next thing we start to do is we combine like terms. And it may not be so easy to see here, but this is an A term, and the second one is an A term as well. A plus ART. Both of those have A's in it. Well, over here, where we have A, how many A's is that? That's one A. Then over here with the second one, that's RTA's. So if I had one of something, and you had RT of something, I could combine those and say we have 1 plus RT of them. Okay? And what did we have? We had A's. So if I do that, it looks more like a factoring property than a combining, but that's because we're not combining numbers. We're combining variables or symbols. So after that, we have P equals A times the quantity of 1 plus RT. Now at this point, it's actually a really simple problem because we've combined like terms. All my A's are on the right hand side. My non-A's are on the left hand side, which is just P. So I'm ready to divide by the coefficient, which is what's multiplying the a? Well, it's 1 plus RT, which will cancel out on the right-hand side. If I need to divide it on the left-hand side, the parentheses are not all that necessary in this example. But in the end, I'll have P over 1 plus RT on the left-hand side, and that'll be equal to A. Let's make that A a little bit nicer. And that is the same formula that we started with, but with A by itself. Okay, so we can isolate variables, and it may seem a little complicated because you're more used to combining numbers or moving numbers around, which makes it a little bit easier for you to feel like you're doing a good job. You get an answer, you can throw it in your calculator and see if it works. Here, if you get an answer, you actually have to physically go back up here, and you said the solution was A equals P over 1 plus RT. You would have to go back up to where we, you actually have to go back up to where we have the A's and plug that P over 1 plus RT in and see what happens, which makes it a lot more difficult to balance out. All right, now we'll get to some practice.